Okay, so welcome to lesson 2 of Mercator Sailing, and in today's video we take up a new type of a question where we discuss how to find the arrived position when a position of departure, a course and a distance is mentioned. So here of course the distance is mentioned in hours and in speed and distance, or rather time traveled. We'll talk about that later, but especially when a distance and a course is given and a departed position is given, how do you find the position arrived? And the other thing that I will show you today is how to carry out an interpolation for finding the meridional paths value of a latitude. All right, so let's start. Remember, there are only two formulas, and we'll use only two formulas for Mercator Sailing. One is cos of course equals D-lat by distance, and the other formula is tan of course equals D long by dmp. So we leave the principles the same. We try to find what has been given to us and how can we find out what has not been given to us. All right, so just because you guys are experienced mariners already, so the question is: a vessel left position 7 degree 43 minutes north, 83 degrees 14 minutes west, steer 235 degrees true for 76 hours at 14 knots. Find the position arrived. Now if the vessel sailed for 76 hours at 14 knots, can we find the distance traveled? Yes, we can. So distance would be then equal to time traveled, right, multiplied by speed. Okay, so time traveled is 76 hours and speed is 14 knots. So 76 times 14, let's do that in the calculators. 76 times 14, I can't even find my calculator. There it is. So 76 times 14 is equal to 1064. 1064 is the distance traveled. So 1064 nautical miles. All right, so we found the distance. So let's go back to the list of formulas and see what do we have. So we have the course steered, we have the distance. So the first formula we can use is formula number 1, because 2 out of the 3 things are given to you. But before we do that, let's do some more from the information that is given to us. So 235 degrees is the course we are steering, right? Course is equal to 235 degrees. Now let's give it a notation of a quadrant notation, because it helps us to name our D-lat and D-long. So what does that mean is that 235 degrees true, where does that lie with respect to north, south, east, west, right? So if south is 180 and west is 270, 235 would be somewhere here, 235 degrees would be somewhere here, right? So what does that mean? That means if I go 55 degrees from south, if I go 55 degrees from south towards west, I reach 235. So the course of 235 would be south, 55 degrees west. So how does this help me? Well, this south helps me to name my D-lat, and this west helps me to name my D-long. That's how it's going to help. All right, so you can see here that the course has been given to. Every time the course is given to you, put it in a quadrant notation so that you can use that to name your D-lat and D-long. All right, let's come back to the formula here. Cos course equals D-lat by distance. So cos of course, so you can use cos 235 or you can use cos of 55. You will get the same answer. You might get a negative value. Just ignore the negative sign, especially when it is distance. Distances cannot be negative. So D-lat by distance. So D-lat is I don't know, and distance is, how much did we calculate? 1064 nautical miles. 1064 nautical miles. I'll just take this here. So keep my known on one side and unknown to the other. So this becomes cos of 235 degrees multiplied by 1064, which is equal to 610.3 minutes. This is my D-lat. Now I have to name my D-lat. I cannot just say 610.3. So remember how to name it. Because I'm on a southwesterly course, my D-lat becomes southwest. So if I have to draw my position A to B, this is A, This is my departure position. I am on a southwesterly course. This is my southwest course, and this is how I reach B. Right, this becomes my course. Of course, this is 55 degrees. Right, now of course this is a plain sailing diagram, so I kind of extend it and make it a Mercator Sailing diagram, where this becomes D long and this becomes my DMP. But in my plain sailing diagram, this remains my D-lat, and this remains my distance, and this remains my departure. Alright, so we've got south, so we'll name it south, 610.3 south. Now because the answer is in minutes and this is more than 60 minutes, I need to convert this into degrees and minutes. So 610.3 divided by 60, 610.3 divided by 60 will help me convert my answer to degrees and minutes. So I will get 10 degrees, 10.3 minutes south. This is my D-lat. Alright, so I've converted 610.3 into degrees and minutes, so I can apply it to my departure latitude. So my departure latitude A is 7 degrees 43 minutes north. My D-lat is 10 degrees 10.3 minutes south. Right? So what will be my arrived latitude? Now remember, if you are at 7 degrees 43 minutes north and you have gone 10 degrees to south, that means you are no longer in the north hemisphere. You have pretty much crossed over to the southern hemisphere. So this time you will just subtract the value. So what you can do is put 10 degrees 10.3 minutes in your calculator, and then put 7 degrees 43 minutes in your calculator, and the answer you will get is 2 degrees 27.3 minutes. So just write 2 degrees 27.3 minutes, and of course you have crossed over to the south latitude, because from 7 degrees north you have gone 10 degrees to the south. So of course you have crossed over to the southern latitude. So somewhere here where I drew the diagram, so from A to B, when you are going from A to B, somewhere here was the equator. You have crossed over the equator. Alright, this is just like an estimation, not an exact drawing. So you have changed over to the other. So now that you have found your departure latitude and your arrival latitude, you have to find your meridional paths value for these two latitudes value. And how do we do that? So we have to use the meridional paths table. So for 7 degrees 43 minutes, which will be a straightforward one, let's go and find that out. 7 degrees 43 minutes. So 7 degrees and 43 minutes will be on this table here. So 7 degrees is here and 43 minutes is here. So if I go down the 7 degrees column and I stop at 43 minutes. So let me just zoom into here. 461.26, right? 461.26 is the value I get. 7 degrees 43 minutes. Alright, and we also need for 2 degrees and 27.3 minutes. Now what you will see is for 2 degrees and 27.3 minutes, so make a note of this value first. So for 2 degrees and 27.3 minutes, you can see that there is no 0.3 minutes here. So what will I do? I will make a note of 2 degrees, and then I will note down the values for 27 minutes and 28 minutes. Alright, so you just go down the 2 degree column and note down the value for 27 and 28 minutes both, and then I will tell you what to do with these values. Alright, so for 2 degrees 27 minutes you have 146.05, and for 28 minutes you have 147.04. Alright, remember these values, as well as remember the value that you found out earlier, 461.26, and we go back to our calculations and show you what to do with that. Alright, so I go back to my calculations. Sorry, here we are here. So 7 degrees 43 minutes was straight off, we will write the value for 7 degrees 46 minutes, which was 461.26, right? But for 2 degrees 27.3 minutes, I have to do something called interpolation. So I will write down the value for 2 degrees 27 minutes, and I will write down the value for 2 degrees 28 minutes first. Let's do an interpolation first, and then I will see which is the correct value. So 2 degrees 27 minutes were 146.05, and 2 degrees 28 minutes was 147.04, right? But I need it for 27.3 minutes, correct? So if I say that the difference on my left hand side when it is 1 minute, so 28 minus 27 is 1 minute. So when the difference is 1 minute, what is the difference in the value here? 147.04 minus 146.05 is 0.99. How did I get 0.99? So when there is a difference of 1 minute here, so 28 minus 27 is 1 minute, and here how much is the difference here when there is a difference of 1 minute? So when the value of the latitude increases from 2 degree 27 minute to 2 degree 28 minute, there is an increase of 1 minute. When there is an increase of 1 minute, the meridional path's value increases by 0.99, right? So when I increase the latitude value from 2 degrees 27 minute to 2 degree 28 minutes, we saw in the table that the meridional part value increases from 146.05 to 147.04. which means that if there is an increase of 1 minute, the meridional part's value increased in this case only by 0.99. So I need to find the value for 2 degrees 27.3 minutes, which means that if I increase the value by 0.3 of a minute from 27 to 27.3, how much should I increase the meridional part value from 146.05? So that I can find out for 27.3. So what do I have to do is basically cross multiplication. So this becomes an unknown, of course. We can call it x. So this means we do a cross multiplication. So x multiplied by 1 equals 0.3 multiplied by 0.99. So x multiplied by 1 is still 1. Oh, sorry, x. And 0.3 multiplied by 0.99 will give you 0.297. So that means if I increase the value from 2 degree 27 minutes to 2 degree 27.3 minutes by just 0.3, I would have to add this value to this MP value here. So the meridional parts value for 2 degrees 27.3 minute would be 146.347. So when you increase the latitude value from 2 degrees 27 minutes to 2 degrees 27.3 minute, I will increase the meridional part value from 146.05 plus 0.297. Alright, so I first found out how much is the meridional parts value increasing when I increase the latitude by 1 minute, that was 0.99, and then I used cross multiplication to find out how much would I have to increase it by if I just increase the latitude by 0.3 of a minute, because I want to find the value for 2 degrees 27.3, which gives me the answer 146.347. Alright, now I have to find DMP, or difference in meridional parts. So one is north, the other is south. Same rules as D-lat apply. Opposite names, add the two. So remember that I found out the meridional parts value for latitude A and latitude B, not the D-lat. So in the exam, students often rush and they find out the value for D-lat. No, it's for latitude A and latitude B. So when I add the two together, what do I get? Let's see, 461.26 plus 146.347 is 607.607. This is the difference in meridional parts value. So I go back to the formula here. So I have already found out D-lat, no problem. So here I have found out DMP, all I have to do is find out D long. So tan course equals D long by DMP. I have found out DMP and I know the course already. So tan of course I can use 55 or I can use 235, doesn't make a difference. So tan of 55 degrees, or you can use 235, doesn't make a difference. All right, you will get the same value. You might get a negative, just ignore the negative sign. Equals D long, which I don't know, divided by DMP, which is 607.607. So this goes here, and D long equals tan 55 degrees multiplied by 607.607, which will give me tan 55 degrees. First let me write it down so that you guys don't get confused as to what I am doing. It gives me 867.75, which minutes, and D long is west because I am on a southwesterly course, so I have to convert this into degrees and minutes. So 867.75 divided by 60 gives me 14 degrees 27 point, is that right? 14 degrees, my D long, 14 D long is 14 degrees 27.7 minutes, and this is west. All right, so I divided 867, in case you were wondering what happened here. 867.75 divided by 60. 867.75 divided by 60 gives me 14 degrees 27.7 minutes. So the D long, similar to D-lat, whenever your D long or D-lat is more than 60 minutes, you have to convert it into degrees and minutes. All right, so I just divided by 60. So your departure longitude, as given to you in the question, departure longitude A was 83 degrees 83 degrees 14 minutes. Whenever I rush, this happens. And then D long is 014 degrees 27.7 minutes, again west. So you are in west longitude and you are going further west. So what should happen? If you are already in west longitude and you are going further west, that means your west longitude will increase. So you add the two values. So you get 097 degrees 41.7 minutes. So you found your arrived longitude and you found out your arrived latitude, and these two together is the final answer. All right, I'll show you more examples of interpolation and I will solve more questions of Mercator Sailing as we keep progressing. For now, thank you for watching today's video. Watch it a few times, have a go at it yourself. Make sure you find out where you are going wrong, and